Let's say that a large earthquake, similar to the 1906 San Francisco earthquake, hits an area where you have real estate. Pieces of facade begin falling down, large cracks run up the side of your building, and everyone is panicking because they don't know if the building is going to collapse. How are you going to determine if the damage done to your structure is structural or aesthetics? And if it is structural, how are you going to know where the damage is located? We are Stasis, and we are creating a new structural health monitoring technology that is going to change the way our country takes care of its infrastructure. We have developed a custom sensor that will measure beam and column bending. And then this information is then sent to our web application, which will then immediately alert the user if there is a problem with the beams, and can also be used to predict when future repairs are necessary. The advantage of our sensor over the competition is that it is completely powerless. So whether you are in a post-hazard event such as a hurricane, a tsunami, or a terrorist attack, and whether the region is powerless or the building is powerless, our sensor will still be working. Our company will have two revenue streams. The first is the sale of our custom sensor to be attached to the building. The second is the licensing of our web application, which is necessary in order to get the data from the sensors. We plan on selling our technology to both building developers and government agencies. In order to market to these, we plan on partnering with engineering companies. They would be willing to partner with us because they would be getting paid by the developers in order to monitor and install these sensors. So there's a beneficial relationship for us. The engineering companies are saving time from doing costly inspections and getting paid to use this equipment, and the building developers don't need to pay them in order to inspect their system. Competitively, structural health monitoring technology, either you need to have power to it or you need to have access to the sensor. Since our sensor is powerless and has no batteries or wires, you can put it in a structure, close it up, and never need to access it again. Right now, in 2015, the market for structural health monitoring was $700 million. By 2022, it is predicted to increase five-fold. We are looking for a partner to invest $100,000 to help us with manufacturing. We are looking for a partner to introduce us to clients and help us market our product. Ultimately, we are looking for a partner to mentor and guide us so we can take our company to the next level. Come join Stasis, and together we can effortlessly and powerlessly oversee our country's infrastructure. Thank you. I would like to call up my teammates Hongjiang Jing, Caroline Chen, Romulo Caliche, and Terrence Brennan to help me out with the Q&A.
I'm wondering what the additional cost is for the developer to add the sensors into their building.
So for full building coverage, that includes every member, we're looking to only increase the cost of large projects by 5%. That's a sensor on every single beam. If you only want to do critical beams, we're looking at around 2%. So we don't want to raise costs because these buildings are already so expensive. We're looking also to make a lot of our money off the licensing of the web application. So once these sensors are we don't even need to do anything. We just license the web application, and every year we're getting a check without needing to do any work.
Can I get one of those?
What's the cost of manufacturing each sensor?
All right. So we plan on using injection molding in order to manufacture our sensors. So there's a large initial upfront cost of about $80,000 to create the molds. From here, it's going to cost about $7 to manufacture each sensor, and we plan on selling them for $15. Then we plan on licensing the web application for $1,500 a year. But let me say one more thing.
You have 20 seconds.
I've talked about implementing our technology in buildings and bridges. But we can also implement them in anywhere else where member deformation is important, such as aerospace technology, where they're trying to implement structural health technology in order for the wings, and other mechanical industries where the deflection of the structure is important and the integrity is necessary.
Good job, guys. How about a round of applause?